Austin says, you.
All right. Hello. Hope you're having a wonderful day so far. Welcome back to the stream. Welcome back. I wanted to try something out here really fast. Let's try something out. Look at that. It's kind of cool. I like that. Did it work? Zoom. Oh, there we go. It did work. Cool. Look at that. Okay. Let's keep that like it is. Why does it? That's cool. Plug this in. Look at that. Now hold on. Alright, so now what I can do is I can plug my iPhone into my laptop to keep it charged.
This way and says good morning.
Alright, look at that new camera setup. Whoop, whoop, whoop. Look at that. That's not cool. I think that looks, does that have better quality? Let's refresh here. Let's go to the stream. Okay, I pop on here. Here we go. That's what it looks like normally. And that's what it looks like with the iPhone. Oh, it's not even that much different. And it really isn't even that much different. What do you guys like better? Do you guys like the iPhone camera here? It doesn't look that much different though, which is kind of crazy. Come on. Okay, I'll try it out for today. How about? We'll see if you guys like it. Alright, today we are back on the grind. I hope you guys are having a good day so far. Happy Saturday to you guys. Today is May 31st, 2025. My name is Michael. I'm back teaching myself some programming and computer science. I hope you're having a good day. Okay, so it's still on my iPhone right now, which is kind of cool. That's interesting. I wonder if I put it to desk view, what happens? Whoa, that looks good. Good thing I had like pants on, right? If I didn't have pants, but that's funny. That's kind of wild. So if I turn it like this, huh? That's fun. That's crazy too. We'll just put it back to what it was. Let's do a little bit that way. There we go. Okay. Alright, let's do one of these problems, yeah? Oh boy. Let's see here. Partition. Given an integer array of numbers of 2n integers, group these integers into n pairs. Just the sum is maximized. I'm not really in the mood to be reading all this. All possible pairings and ordinary pairings. Any numbers of 2n integers. Group these into pairs and pairs, right? It's maximized. Oh, gotcha. So you have to find the sum of min and b. So this one has 1 and 4. 1 and 2 get paired, 3 and 4 get paired, right? You have to pair the top. You have to pair in reverse or descending order, right? Okay. So in this one, the optimal is pairing 2 and 1, obviously 6 and 6, and then 2 and 5 together. Okay, so the arrays aren't sorted. Do we want to first sort the arrays in reverse, right? But we don't want to sort because How can we do this without sorting? Let's think. Right, so the key here is we want to pair the numbers in descending order. So 4 and 3, 2 and 1. And in the bottom case, 6 and 6, 5 and 2, 1 and 2. So if we like binary search, it'd be like n log n, right? Each number goes through a log n process. So if we did a binary search for the maximum, so if we come across, let's just brainstorm here. What do you guys' ideas? You guys have any like initial ideas or you guys are thinking about? Let's brainstorm together. So let's say we come across, if we want to try it in order, so we have 1, 4, 3, and 2 here, right? So if we don't sort right off the bat and we come across the 1, okay, right now, right at the jump, we know that our max is currently 1. So that would become can we do it in a linear approach is my question. Because we're wanting to but then we don't want to delete numbers either. Like if we binary search, no, but interesting. We're trying to maximize sum. So if we loop over, we come across to 1. This becomes our max. The thing is once we hit then we hit the 4. So if we have like a sorted, right, this would become, now what if we do 2-pointer here? What if we have a left and a right? Where we compare these two values? Okay, in this case it would be 4. We keep that and move this pointer forward. Put the least, put the smaller onto a what kind of approach should we do? Like if we do 2-pointer, let's say we're looking at both the 1 and the 4 here. Well, we know that the 4 is the max, so that would become the max. We would move the 1 forward compare to this guy. Move that forward compare, because we found our max. But then we would have to go back and loop over. So it'd be like n over 2. So once we come across a value, once we reference a value, we can, the thing is should we sort and then do it? Or can we do it without sorting? That's my dilemma here. What do you guys think? Anybody have any ideas? because the whole purpose is the trick is if we can do it is if we get sorted in reverse or in descending order, so highest to least, greatest to least, and then right, and then go ahead and pair up down, right, or sort it or from greatest to least and then go backwards. So if we come across to 1 and we come across to 4, I say the 4 is my A because it's the bigger value, and I say my 1 is my B. Okay, let's just try this. So let's say, hey BizWyan, how's it going? We're talking through this one. Welcome back in.
IDK. You have 65 Leet code questions. Come to my one.
Honestly, these Leet code questions, they all merge into they feel like one question, the same question. Okay. Let's see here. So what if I do this? So we have max up here. So we have a left and right pointer. So we have a left and a right. Well, right becomes max, so 4 up here. And then we have, so right, and then A becomes 4. And then we go forward. And then we move L over. And now we're here onto the 3. Well, then this is bigger, and then B would become the 1. Well, this is bigger, so this would replace to become 3. And then we would move B one more time to here, and now we found a valid pair, the topmost pair. So we would probably want to keep track of indices to right. We found a top pair. So then but then how can we eliminate these values? So that's why I'm thinking like a second data structure.
Biswayan says hint, since it is 10 so it can be O, n to the power of 2.
Since it is less than or equal to 10 to the power of 4. Yeah, so there's definitely a brute force way, right? You can definitely, the brute force way is easy. You can just go on the first number, check to find the maximum, and then find the least, right? You can just kind of brute force sort it. But can we, I don't know. Let's just see, can we go like this? Let's just call nums dot sort, right? We'll say reverse equals to true. Okay, if I print, I always have to remember here this dot sort versus sorted. I made a, yeah, okay. So now if we say for, say, n equals equal to the length of nums, say for I in range n, we'll say n minus 1. I say j say A is equal to this, B, no. I and J is equal to I plus 1. We're going to say we're going to say let's just go sum or total. Okay, here we're going to say total plus equals to the min of nums index I plus nums, or nums index I, nums, such as the sum of min A I B for all is maximized. J return total. So the thing is though is we want to skip. We don't want to do the same number twice. We want to move past.
Wayan says this type make me confusing minimum then maximum.
So the thing is we want to skip over already seen values though. So that's why I think it was like, let's do this. Let's, instead of sorting reverse true, let's just do sort. Let's do this. Total equals to 0 while nums. We're going to A is equal to nums dot pop. B is equal to nums dot pop. Let's say total plus equals to min of A and B. Return total. How about that? So while there's numbers in the array, we're going to pop 2 numbers out at a time, starting from the right, and then take the minimum total and return it. Oh, let's go. Slow though, we slow. We knew that was coming. Okay, now how can we speed this bad boy up? Definitely not the fastest way to sort, so we gotta speed this up.
This Wayan says yeah.
Right. So now we don't want to sort, so if I pop it.
This Wayan says but okay. This Wayan says 39 milliseconds fast.
There's definitely some better solutions here based on the curve.
Arya says good job by the way.
Thanks, Arya. All right, now we need to optimize this one. Obviously, we can't sort. We need to do it in place. So what kind of trick can we do in place? Because we need to find maximum pairs, meaning that we need to pair up the 2 largest or the pair up numbers in order of largest to smallest, right? So do we do a sorting algorithm and then just do this at the same time, right? So do we do our own sort? We might need to do that, right? So we'll have to do like our own sort here. This might be like a sorting problem. Oh, crap. So we got to do our own sort. So we need to say, if I pop off the 2, I have a value. Right, so we can keep this part here, but we need to, I think we have to sort in place, right? Or is there a way to not sort at all? Let's check, let's read a hint. Yeah.
Biswayan says, what does tag say? Lies in which topic this question?
Array, greedy, sorting, counting sort. Yeah. So basically just on each sorting operation. So that's the trick here. So you do your own sort and then you just extract the values at each pass. So it's O of n, or no, it's not would be O. So I wonder like this, I wonder if there's a trick. Let's say scene indexes. Or we'll say used indexes. Right? Use index is equal to an array here. No, not an array. We're going to say it's going to be a set. Okay, and we can say, let's go for, we're going to have a max, or a equals to none, b is equal to none. We're going to say while nums, no, let's say for I in the range, for I in range.
Biswayan says count sort will make fast, that's why.
We're going to say, and then we're going to say that n is equal to the length of nums, right? So I wonder if we can say for I in the range of nums, or n, right? We're going to say, we're going to do this so let's say while I'm gonna make this way complicated, but I have an idea.
Biswayan says fastest sort algorithm, as it takes TC, n plus k, and SC, n.
I have an idea. Let's say,
Biswayan says SC is issue in count sort.
okay, so let's set a copy here. Let's say while copy greater than equal to 0. So copy is equal to n minus 1. So while copy is greater than or equal to 0, we're going to say for I no, because that'll be n, that'll be 2, that'll be, because I was going to, that'd be O of n squared. Because I was going to have you pass over the index of already used values, which I think will be even worse than our one before. I mean, we'll try it. Let's just keep going. So for I in range n, we're going to say a, or we're gonna get a max or an a here, or a is already here. We need a and b to reset to none on each pass. We will then say we'll say nah, that's just dumb. This is too finicky. So I'm gonna look up count sort algorithm. Oh. Count sort is a non-comparison based sorting algorithm that is particularly efficient when the range of input values is small compared to the number of elements to be sorted. The basic idea behind count sort is to count the frequency of each distinct elements in the input array and use that information to place the elements in their correct sorted positions. For example, oh, so you just count and then put them out. Okay, so let's do this. Count is equal to the map here. We're going to say for num in nums count. We're going to do for num in nums. If num in count or try count num let's equal 1 except key error. This is stupid. I probably shouldn't do this. Count. So if it's not there, we could just say
this
if
way
no.
It says, oh, I realized. You were popping 2 elements instead. You should iterate from index n2 -1 -1 pop takes time.
Yeah, but I sorted first, right? So I was popping things at the end. They were always the greater values. So those were constant operations, albeit n constant operations, but yeah. On an overarching loop of n divided by 2, then times the sorting algorithm.
Tim says Indiana versus Oklahoma City in the NBA Finals. Mike, is this gonna be the least watched final
Oh,
ever?
for sure. 2 small markets. Yeah, definitely. So we'll get the count. And you say so if we get the count of every element through one single linear pass, can we then, how can I?
Tim says gonna sell Nvidia to bet the under on viewership.
go?
I went to the gym.
Oh, nice.
I'm going to movies at 8.
Okay. What are you gonna go see?
What?
What are you gonna go see?
I'm going to see Friendship.
Oh, that's not okay. Okay, so if Nums is in count now, how can we? We're gonna say while count count.get.
Tim says Mike scammed us out of league again.
Maybe tonight we'll play if I feel it.
2020 says, league code combinatrix week is gonna ruin me for dailies Mayo.
So if we say count, we want to get no. So we have all the counts, and so then what do we want to build basically? We want to go through them while count.
Devgood 2020 says, have you done the daily?
No, not yet. We're just working on this one. This is the first one for tonight. So we're going to we're going to access the count dictionary while we have count, and we're going to, maybe I should save it as the index. So let's go. No, because find out the maximum element in a given array. Kind of each unique element in the input array at their respective indices. Store the account of each unique element count of element. So that's what we're doing. And we can determine a maximum. Because we're looping over determine a maximum. A index I minus 1 plus 2, 4, 7, 7, 8, because we need the count array. Input array because we're using input array. Let's see if the index of 5 is 8 counts. No. Not making much sense. Okay, so if we get all the counts, can I just delete? But how do I have? I know them. I don't have them in order by greatness, by maximum. Right. So I need to know the maximum on this pass so I can Let's look up.
Here's a quick introduction to counting sort. Let's just say as an example, we are trying to sort this array into an ascending order. And counting sort works the best when the range of numbers each value could have is very small in the array. So let's just say the range of values that we could have for each item is 0, 1, 2, and 3. The first part of applying counting sort is going to be finding the starting index for each number. And it's going to be clear what I mean by that in a second. And the first step for doing that is going to be counting the number of occurrences for each number in the array. So for this example, there's only one occurrence of 0 and 3 occurrences of 1. So I'm going to write down 1 and 3, and then
so use an index as the value. Okay, so let's do this. Let's say count is equal to an array, right? And we're going to say for num in nums, we're going to say if we're gonna make a, this is gonna be of, we're gonna say the length n is equal to the length of nums, and we're gonna make this be 0 now we need to find the maximum and then make an array the size of the maximum. So you give an input array here. And it's a maximum of 5. Find out the maximum of the given array. Yeah, so you do have to do a pass. So let's go max is equal to max of nums. We'll say for I in range of max plus 1, right? Because we need to, maximum will go 0 to up to maximum when you go when greater than maximum, because count is going to be established as up to that number. For num in range, or sorry, n for n. No, I'll say of maximum plus 1, right? And then we're going to go iterate over the range of maximum plus 1 here. We're going to iterate over the length of, of nums, which is n. Maximum. So hold on, if maximum is, let's say you have maximum is 4, so that is equal to n. That means that we have 4 places in the array, 0, 1, indexes of 0, 1, 2, and 3. So we need to have, we're not counting 4, so that's why we have 4 here. So this would be 5, or n plus 1, right? which is maximum. So we find the maximum, which would be 4 in this case. So let's go, hold on. So let's look at the case of like 1, 2, 3, 4, okay? We would iterate, find the maximum. Okay, we found a max equal to 4, right? We found a max equal to 4. So if that's the case, then we're going to create an array of size of 4 plus 1, right? Max plus 1. So this is count, right, is equal to an array of 0, 1, 2, 3, 4, right? We loop over, so for I in range of length of, we'll say, right, maximum, max plus 1, we're going to say we're going to say for I in range of max plus 1, we're going to access if I, we're going to say, so this is our array here. So it's going to loop over here.
And 2 occurrences of 3, and 0 occurrences of 2. And we can store these numbers in an array of length 4 in this particular case. Once we have these numbers, the number of occurrences for each number, the second step is going to be adding each number to the right of it accumulatively. What I mean by that is the first number at index 0 stays the same, and the second number will be 1 plus 3 equals 4, and the third number will be 4 plus 0, which is equal to 4.
Dill says,
And
yo,
the
genuine
fourth
question
number
why
at
learn this
index
is so is
3
going
will
to
be
just
4
automate it.
plus 2,
I'm
which is
currently in
equal to
cyber and
6.
I'm trying to pick up some
After that
programming
step,
skills.
we
Just
have the
wanted to see
numbers
what your
1,
reasons
4,
are.
4, 6 for the numbers 0, 1, 2, and 3. The next step is going to be shifting this whole array to the right by 1 cell. And we're going to do that by looking at this array from right to left. We're going to first start with the last index, which is index
Dill
3
says
in this particular case. And the value there should be the value that's currently in index 2. So we're going to put 4 at index 3. And we're going to do the same thing for index 2. The value here should be what's in index 1.
Okay, let's just, hold on. Let's go back to my previous approach where I was using my
Othello
dictionary.
says raw dogging Python with no music is crazy.
I had music on, but we're watching the video. Here you go. All right, so let's try it this way. So we have a count. We get our account, right? We're gonna say,
Luca says, yo, I'm trying to learn Python from Crash Course. How much time should I take to finish the book because I feel like I keep forgetting what does what? Angus says, do you already know Python?
so hold on, let's say this.
Sir Men says you should have a for loop iterating over the thing after dot sort.
Please don't spoil. I've already solved it. We're trying to optimize it here. All right. So, oh, my bad. Okay, so we're going to get a count. We've already solved it here using the sort. So we're trying to optimize it for a better approach here with like a count sort. So we're getting a count here. So then can we say For-
says, basically understanding the sorting algos are good for like low-level stuff.
For
If
key
you want
value
to know, like,
in
high complexity stuff, both in terms of what sorting algo you
items.
pick, or like looking up what sorting
say-
algo programming languages compilers implement under the hood
let's
when
say,
they use the built-in sort function. Devka 2020 says, but ye, most of the time
Let's
sort
do,
algo templates are a chat away, or a Geek for Geeks visit. Sermon says
Sorted.
and login a probe. Angus says, I don't understand how people know how to optimize it. Like, what are you optimizing and how do you know how fast it is?
Okay, so then, so we see this, we're going to say for key value in count.items. Let's go ahead and establish.
Devka 2020 says, optimization in Leet code comp programming
Can't
falls
focus
under
with
the
the
old-time
TTS, sorry
complexity
guys.
scores.
Okay, so we're going to say for key value in count.items. So we're going to access the count.items. We're going to say, so this is going to key value sort. We're going to go sort nums dot append. We're going to append the key so if I say for I in range of value, or source say for sort nums dot append key. So that'll append the number we want. No, that just appends it back in the same count. No. Because we never actually sorted it in this case. So we do have to use the sort. Okay, so counting sort, let's walk through this. So we have for num in nums, if num, okay, so if we have a count though, but can I make a prefix, but I don't know the max, I could determine the maximum here. Prefix, wasn't, let's go back to this.
1 currently, so it should also be 4. And at index 1, we're going to put 1. At index 0, we're going to put 0. And these numbers, 0, 1, 4, 4, are actually the starting indexes for the range of numbers we have in this particular case, 0, 1, 2, and 3. And here's one way to think about it. If you look at the number 3, or the index 3, the corresponding number, the corresponding starting index is 4. And that's because when we sort this array, the number 3 will start at the index 4. Another way to think about it is that there are 4 items that should appear before the number 3 in the sorted array. And that should be obvious if you just look at the first array that we constructed. There's 1 occurrence of 0, 3 occurrences of 1, and 0 occurrences of 2. So adding them up, there are 4 items that should appear before the number 3. And that's why the starting index for the number 3 is 4. Once we have the starting index for each number, the rest is relatively easy. We're going to first initialize a new array that's
really
the
hot in
same
here.
length as the original array, so length 6 in this particular case. And then we're going to iterate through the original array one by one. When we're looking at the first element of this array, which is 1, we're going to check what the starting index should be for this number from the array that we constructed. we see that the starting index is 1, so we're going to put this number into index 1 of the new array. And then we're going to increment our starting index by 1, and it becomes 2. And this is so that when we look at the second instance of the number 1, we'll know that it should go into the index 2.
So, interesting. Okay, so you need to know what index it goes into, right? That's the thing here. I'm gonna have to crack the window though for sure. Crack it open. See, we solved it just slow. Okay, so, but if I can go through the array. Yeah, it's 8 o'clock. It's still daylight here in California. Okay, let's go like this. Let's say, I'm gonna give it my first submission. I'm gonna say, this is how I solved the problem originally. I am working on Leet code 561, and I solved the problem using built-in sorting, so it's not the best. I would like to learn how to improve this solution. Could you coach me in gaining a better understanding of the concepts needed? Do not show me any code. Guide me with words and pseudo. How do you spell that? Okay. Great job in getting a working solution for Leet code 561 array partitions. As you're aiming to improve it beyond built-in sorting and want to develop a deeper understanding, let's walk through the problem and the concepts that matter. So you're given an array of 2 n integers. You're needed to pair them up into n pairs. For each pair, take the minimum value. What you did well. Your current solution sorts the array, pops the largest 2 elements, and computes the min and adds it in that total. That works because sorting ensures that you always pair smaller numbers with the closest larger ones. Maximizing the sum of the mins. How to improve. Let's discuss conceptually that can improve your understanding and how you can get closer to an optimal solution. How do you find the min or max in an array? You would just loop through and keep a tag, right? So you use the min or max function, but you would just have to. It takes, obviously, right? You just loop through and find the maximum, and just retain it, and check on each value. A linear approach. Can you do it? Well, if it's sorted, you just take the last one, so it's constant. So it's unsorted, you have to check each value. Yeah. Okay. How can I make the locality optimal choice prepared to ensure a global optimal result? In this case, pairing the 2 smallest numbers together ensures that the smaller number isn't wasted by being paired with a very large number. Think, after sorting the best, we got it. So if you sorted this, the best pairs are 1, 2, and 3, 4. Some of the mins is 1 plus 3. Sorting versus counting. Your current solution uses dot sort, which takes n log n time. The problem constraints are small enough that it passes, but you want better. What do I know about the input? If the integers are bounded to this, then counting sort becomes a viable tool. Counting sort insight. Instead of comparing elements, you count how many times then each number appears and simulate pairing using a frequency table. Frequency table plus greedy pairing. Imagine walking through a frequency table, or a frequency array from lowest to highest value. You keep a flag like you should pick equals to true.
Othello says here in the explanation it says you need to make pairs then sort min and sum it.
Yeah, we solved it already. We're trying to optimize it here, my friend. When you see a number x and should pick true, you add x to your sum. Every time you see the number, flip the flag. Imagine you're walking through a frequency array from lowest to highest value. You keep a flag like should pick equals to true. When you see a number x and should pick equals true, you add the x to your sum. Every time you use a number, you flip the flag. This avoids actual sorting and runs in a linear time of O of n plus k, where k is the value range. Mental model to practice. Sort the array, pair adjacent values. Always pick the smallest. The pair for summing. Use a histogram number for frequencies. Simulate the greedy selection by alternately picking through the sorted values in counting order. Okay, so if we determine a maximum, m is equal to the max of nums. We then say frequency is equal to an array of val for val in range of m plus 1. We then say for I in the range of length of nums, frequency at index of I plus equals by 1 no, we'll say for num in nums. Or I'm just going to loop over those. So the thing is, can I do this while finding the maximum? So I'm going to have let's do this. Find max. Let's do this. For num in nums, right? We're going to say, we're going to have a list of frequency here. It's equal to some array, and m is equal to none here. Nums index 0. No, because we need to get a... So let's say for I in the range of length of nums. So we're going to loop over the numbers range here. So for I in the range, length of numbers. So this will give us the index or, right? Which we're going to find a maximum value. So max is like, if the max is 0. No, we don't want to do that either. So let's just, let's just find m is equal to the max of numbers. And then, for every number, let's have frequency, right? Frequency is equal to an array. A val for val in range of m plus 1. Right, we're going to say for num in numbers, we're going to say frequency at the number index plus 1. So we're going to come across a, let's say, a 1. We're going to go to frequency at index 1, which will be the value of 1, and increase its value. So actually, so this will be, we don't need to do a loop here because we just want to say, make a dummy array with zeros times m plus 1. Right? So we're going to go into frequency at the index of the number and assign it to there. So now if I go ahead and print frequency here and just run a test here. Right, so we get 0 zeros, we get 1 1, 1 4, 1 2, 1 3, and 1 4. So can I go like this? Now that I have this frequency count, can I just loop through and make an A? Can I just make an A and so can I go just drain them all basically?
Tirafinail says, just a tip, before you write code, a pen and paper brainstorming of the steps involved, then it
trust
just
me, bro,
becomes
we've been
easy to
there.
code.
Trust me, dude, we've been writing stuff. We've been writing stuff for a while now. Okay, we've already solved it. We're just trying to optimize it to learn a
Riya
different solution
says it
here.
equals Nayan 100, Surya 23, Kamina 34, Chapri 240, Print, Aso. How I change the value of Kamina. Othello says, Terra Boomer finale. He just asked the built-it-in I for help instead.
Calling him Boomer. Ria, you would just, how do I change the value of Kamina? Just access the A at index of, quote, Kamina, and update the value equal to a new value. So A index,
Tim
quote,
says
Kamina.
Mike's notebook is filled with lead code brainstorming.
Okay, so I'm just using the AI here to walk me through how to learn without any code. I'm writing all the code, how to learn the frequency sort here. I've never had to use the frequency sort before, or counting sort really. We're trying to learn that one here. We solved it by just by sorting it using the built-in sort and then popping off the greater values and taking them in and updating a total already. But there's obviously a better solution here that we're trying to work on. But we're not going to be here all day. So for numbers and numbers, we're going to update the frequencies. Now I've got the frequencies. Now can I exhaust all the frequencies, right? Can I say, okay, can I loop through the frequencies and then say for, can I go like this, like total is equal to 0, and say for I in range of length of frequency, right? Well, length of frequency is m plus 1, so we don't even need to do this. This would be just m plus 1. We already have reference of it. Could we go like this and then say, could we say, and then do an inner loop and say for underscore in range of frequency at index of I, right? So this will do the count. We're going to go into this inner loop and update total plus equals to nums at index of I No, we don't need to do this inner loop either. We can just go like this. Total plus equals to the frequency at index of I times nums at index of I. And then we return total here. I think we got it. Hold on, let's think about this. So in my test result here, we print out the frequency. This will give 0 zeros, 1 1, 1 2, 1 3, 1 4, which maps to this. So this will take 0 zeros plus 1 1 plus 1 2. No, we don't want to min, right? We want to find. Oh, I think no, we're not telling a total. Hold on, we're doing a min. Oh, that's right. So we're doing a min operation. So that's why I was exhausting the values. Oh, shoot. No. Right, so for I in the range of m plus 1, we're not just updating the total here. We don't want to find the number by its frequency count. That's not what we're trying to do. We're trying to, we got the frequency count. Now we can build the sorted array basically, and then we can loop through the sorted array and make pairs. Okay, so then we have the frequency count updated. So let's go sorted nums is equal to an empty array. I'm going to go for well, now we're just doing no, because now we're just doing two linear approaches, and I think the problem is supposed to be n plus, so let's go for so I need to loop over I need to build the sorted array off of the frequency. But no, but I don't know that's the thing. So I have to build a prefix sum. Update the frequency. Okay, I'm gonna say You're off to a solid start. Implementing the counting sort idea. Nice initiative. Finds the max. Populates. What's missing?
DevGood 2020 says, we call it prefix summy in this house.
Prefix, which is an invalid index if it's a negative 10. Because they can be negative numbers. You need to offset the index by to handle negatives. So I need to offset the index to handle negatives. So we're going into frequency at that number. Yeah, you can't access a negative 10 index. Oh, dang. So this doesn't work for frequencies either. Oh my gosh. This sucks. I've been working on this for way too long. I'm about ready to move on for today. I mean, we already solved it, but just not optimally. You offset the index to handle negatives. Offset equals 10,000. $20,000. Oh, to handle the constraint. Huh. Well, it's alright. We'll give this one another go. We'll try to optimize our solution another time. We spent too long working on it though. Let's try a different one.
Praveen says, bro, how much you are earning through live?
Pennies, my friend. Pennies. Rising temperature.
DevGood 2020 says daily. DevGood 2020 says is cool.
That's a sequel. Distribute candies among children too. You're given two positive integers, n and limit. Return the total number of ways to distribute n candies among three
Praveen
children.
says how much?
Pennies, dude. I told you. Pennies. Cents. 10 cents. 5 cents a stream. Like, told you, man. Among three children, no children gets more than the limit. Oh, sorry. Return the total number of ways to distribute n candies among three children, such that no children gets more than the limit. Okay. So if the input is 5, and so n is distribute n candies, so number of candies. So 5 candies, no kid gets 2. The total number of ways to
Praveen
distribute.
says, I am from India, I can't understand.
There are 3 ways to distribute 5 candies, such that no child gets more than 2 candies. Okay, this is just hitting my brain like recursion here. Right?
DevGood 2020 says Praveen. Basically penny and nickels are the smallest currency coin we have. Tim says he makes 10,000 rupees for each stream.
There are 3 ways to distribute 5 candies such that no child gets more than 2 candies. 1, 2, 2, 1, 2, 1, 1, 2, 2, 1, yeah. Then 3 candies with a limit of 3 for each. there's 10 ways to give. You can include 0. Oh, so you have to give that kid candies because you couldn't give more than 2, so you had to dish out the
Praveen
candy
says
here.
which eye you are using.
Okay. There are 10 ways to distribute 3 candies such that no child gets more than 3. Okay, so if we wanted, I think we can solve this recursively is my first kind of, what's kind of ringing my bell here. So we would need to come up with okay,
Devka
so
2020 says, big, look at the constraints.
oh yeah, so but the thing is like the thing is with the constraints is recursively can we just cache results like if any of the indexes like this is 003 is the same as 030. It's just it just depends on which kid is getting it, right? So hold on, my dog's trying to get in here.
Praveen
Hello,
says
sorry.
PLS tell me.
I'm just using the chat GPT, man. Every once in a while when I need some help and to learn some more stuff. So right, the 003 and the 030 and the 300, those are
Tim says I
there's no
solved the
difference.
previous array problem with bottom 6% runtime. I quit.
What was your solution, Tim? Yeah, it's a trickier one, huh? For sure. For getting like a more optimal solution. So can we not just but the N, we can have a lot of candies though. Oh god.
Praveen says I voice how it happens. Tirafinail says hahaha. Devka 2020 says 10 cap 6 candies, then 3 kids that could go from 0 to 10 cap 6 each technically. Praveen says which
Yeah.
chatbot you are using for that. Devka 2020 says so time
just
could go
social stream.
really brr.
So time could really go, yeah. So 0 to 10 to 6. We can enumerate the number of candies of one particular child. It'll be I, which means 0 is less than or equal to I, which is less than or equal to the limit, and N. Okay. So you can give a child
Praveen says
as many
Devka, who is
candies
this?
as up to 0 or the minimum of the limit or the number of candies, whichever one is the bottleneck. So we can say but the thing is how can you like continually
Devka
sum?
2020 says, I'm a Twitch viewer.
So the thing is, DevGod, is how can we sum all the way up to like upwards of 10 to the power of 6? Like, right, so like because technically you can give one child as many candies as either the min of the limit or N is basically what this is saying. So can you say
Devka 2020 says, without giving it away, there are a couple of different ways. Art 2005 says, how was your Saturday?
for blank or like for child in the range of 3? We're going to do 3 children loops here. We're going to give every child that's just one approach though. Oh gosh. This is why I stick to the easies, boys. This is why I stick to the easies. The thing is the constraints are
Tim
screwing
says,
me
did
here.
the dog go to the park, Mike? Free the dog.
Yeah, we took the dog on a walk today. What the dog doing? So we loop over 3 children. If you give each child that's just one combination. And then that combination can be repeated for each child, basically,
Devka
right?
2020 says, there is like a greedy counting way, and a combinatrix way. I also think there could be a digit DP way maybe as well.
Yeah, I don't know. I don't think I'm ready for this guy yet. I don't really know those tools yet. Know when to hold them and know when to fold them. We might have to pick an easier one and lead our way up there. I don't know the greedy counting yet and combinatorics.
Devka 2020 says hold M and fold M lol. Ho says a bit of discrete math.
Yeah. Dang it. That makes me feel dumb.
Tirafinail says tough combinatorial problem tricky one. Devka 2020 says, shout out to Python's built-in comb function by the way. Tim says yeah that's tricky. Devka 2020 says
Everybody
this was the
seems to be on
first
the same
Python
page
night
here with that
instead
one.
of JS night in a while.
Oh, gotcha. Pointing key, palindrome, linked list, valid anagram. Should we do a linked list problem? Oh god. Given the head of a singular linked list, return true if it is a palindrome or false otherwise. So if it just is repeatable from front to back. Okay, this is not, I don't think this is that hard. Let's go, string is equal to, let's go for or while head, right? String plus equals head dot value, head equals head dot next. So we'll just go through and then we'll say return string equal to string flipped.
Devka 2020 says oh follow-up is a bit tricky.
Oh, let's go. Another slow boy. Another slow one in the bank here. So we traverse. Dang it, slow. We got that one fast though.
Tim says maybe Mike's computer is just a slow poke. I'm coping.
Okay, so let's think about this one now. Right, do we need to... Well, the thing is you don't know the length, right? You only know when it ends. And you can't start from the back, you only have reference of the head. So So they got it in half the time, which means they looped over half the amount I did.
DevGood 2020 says so. Follow up O. N. Time is one run through of linked list, and then O. 1 is like you don't use any extra array or string to solve it that way.
Yeah. Wait, so follow up? What do you mean follow up? Is that what this is called? Follow up? No, this is Palindrome.
DevGood 2020 says at the bottom there is the follow-up challenge.
Oh. Yeah.
DevGood 2020 says bottom of the problem description.
All right, O of n time and O of 1 space. Yeah, so we can't use the string. So how can we identify just by passing over? How can we follow it? How can we do it just by passing over? Well, what about this? Like, what if we sandwich it together, right? Meaning, like, what if we fold the linked list in half? Now that's what I think. That's what I'm thinking. So like, what if we have a linked list that goes like 1 to 2 to 2 to 1? What if we fold this linked list in half, basically, wrap it around, and make it go like, it'll look something like this, where it was 2 to 1 for the end, and then 2 points
says, oh,
and
yeah.
1 points, right? So it goes like this. It has 2, 1, and so now these are lined up basically, right? So this wraps to here, right? We've folded this on its midpoint.
DevGood
And can we now
2020
check?
says then you could do like the turtle and hair pointer thing.
Turtle and hair pointer thing. Yes. Okay, so how can we set this up? So if we wrap, we need to find though the midpoint.
Tirafinail says how would you detect a cycle? Just a tip.
Just a tip. Just a tip. You guys know what that's from? Let me know. OG videos back in the day on YouTube. What YouTuber made that slogan of just a tip? So how can we detect a cycle here? Is if we caught back up to our character. Okay. Okay. So if we caught back up to our lagger, if our leader caught back up to our lagger, we've caught a cycle, and that is over. So let's say we have a cycle. We have 1.
Tim says Mike referencing a YouTube video from 2007.
Right. So what? Okay. So we have a lead. We have the rabbit, and we have the hare. Or no, so that's the same thing. We have the rabbit and we have the turtle. Let's do a hare and the turtle. We have the hare
says yes.
and we have the turtle. Right? So if the hare moves at double the speed, so it moves, and now the hare's here, and the turtle does not equal the hare here. So now the hare moves, now the turtle moves. Now the hare moves, now the turtle moves. So we want the hare to move at double, could call next, and the tail to lag behind by 1 call, and then but keep track of values that the Okay, how can we set this up though?
Khalil says be careful with how you initialize the turtle. Yeah,
so that's the thing I'm trying to figure out here is the turtle we don't want to have the hair jump characters, right? If the hair jumps spaces, we need the hair to track values because it'll lead. I feel like I'm being loud as though. Close the window. So we need the hair to track values here. So let's redraw. So we got 1, 2, 2, 1. So if we have a hare and we have the turtle, right? Could I use even odd, right? Could I use a counter? If the counter is even, then go ahead and move the hare. If the counter is odd, move both. Right? So if the counter is even, or if the flag is even, move both. If the flag is odd, move just the hare. So the hare will move at double the speed. So the here goes here. Okay. And then now on the second pass, that's on the first pass. Now on the second pass, the turtle will go here and the hare will go here. So once the hare equals the turtle, that's when we stop. Because the hare will catch the turtle. And at that point in time, no, but the thing is I need to do this in a single pass. I'm not keeping strings, right? I need to. I'm not keeping strings, so I need to somehow basically build 2 linked lists and then compare those. No, but that's
Raphinael says when they point to the same node,
you
a
set them to
cycle
none.
detected.
Yeah, when they point to the same node, a cycle is detected, and can you set whatever they're pointing to be none at that point in time and then detect if they're equal, and then right? So let's look at this. So the hare moves up on the first pass to 2, and then on the second pass moves up to this 2. On the third pass moves up to this 1, and then on the fourth pass this moves up, and now the hare is back here on the fourth pass. On the fifth pass comes here. So can I say so I say that lead equals to head and lag equals to head. Okay, say lead is head dot next. So I say while lead does not equal to lag, I'm going to say flag is equal to 0. I don't know if this is the right way to go about it, but flag is equal to 0 if flag right, modulo 2. So I'll say if flat, I'll just say on the first pass you move one. So I'll say false. You don't move both. So I'll say move both equals false at the first go. So if, oh gosh, bruh, gonna get canceled. Gonna get canceled. Brutal typo. Brutal typo. So if flag, or if move both, right, then we call lead dot next lag dot next, else just lead dot next. Okay. While lead does not.
Tim says rip Mike's career, it was a good run boys. Slow says LeMayo.
The YouTube delay. Okay, so am I on the right track here, boys? What do we think? What do we think here, my boys? My gents.
Tirafinail says ha ha ha.
Okay, so if move both, else we'll say, and then we'll set this move both equals to false here. This will be move both equals to true on the next pass. Okay. So if we set at the end of this lead dot next is equal to none, lag dot next is also equal to none, and then do we say if return lead equals lag. Infinite loop. Ugh. Else lead dot next. So lead is head dot next.
Says you can simplify it, both point at the head and have one step by one and one step by two. Use turtle to find the middle.
That too, right? So this one we're using a circular approach, finding when the lead hits the lag. On that approach, that one's just having it move two and then stopping, and then okay, yeah, that's a good idea too. But if we're trying to find out what the circular approach, before we give up on this approach and try just by doing 2 to 1, what is my infinite loop here? So move both while lead does not equal lag. If move both, you move lead, and you move lag forward. Else you just move. So on the first pass, lead and lag do not equal each other. So we're going to move lead forward in the first pass. We then on the next, so then on the next pass we're gonna move both forward. So then we don't equal each other, we're gonna move both forward. Then we set the next pointers to none after once we caught to the front. Return lead equals to lag. So it's clearly our loop. They never equal to each other. Test result. And limit exceeded. So lead. No, not if lead equals to lag. No, because... Oh, okay, hold on. Once the lead will move to none, it won't loop around. Hold on, so let's do this. Let's set them both to head and say move both. Let's say while lead. If move both, we'll move both, and then set to false, else we'll do this. So if move both, lead.next, lag.next, move both, else lead.next and move both equals to true. Infinite loop. Really? Dang it. Dang flabbit. I'll lead.
Toes says I don't understand circular approach. Doesn't this only check references, not the actual values?
No, it's values. Well, I mean, if you... Or I'm not sure. I don't know. But I'm right there with you. I'm trying to figure it out. So... lead equals head, lag equals head. Move both is equal to false. While lead, so while lead does not go to none, we'll move both. So this is not going to hit because move both is false. We don't need to... move lead forward. Lead always goes next. What? Why is this infinite? Anybody know why this is infinite? So while the lead, if the move both, which in this first case is not, so it's going to hit this, we're going to move lead forward and then set the move both to true. I need a snack. What do we think, you guys? Let me grab a snack.
Tirafinail says while Leet an. While we am. Sorry for being Captain Crunch. Oh gosh. Okay. While lead and. We need an and. And what? And lag? No. Tim says crunchy asthma.
Anyone have any ideas?
Says you do not advance the pointer.
I don't advance the pointer. Am I blind? I call lead next in both situations.
Debka 2020 says, messy but I have rememed myself. 2023 Debka converted this to an ArrayLMAO link.
I move lead forward both times. If move both. So that's not going to hit. This hits. And we set move both to true here. So on the next pass, am I blind, you guys? Dude. If move both lead.next and lag.next. While lead. Are they method calls like this? Are they method calls? I don't think so. Dude. Or am I wrong, you guys? Do I need function? Do I need these? Am I just being dumb? No. Not callable. I do not advance the pointer. Move head forward. This is going to be infinite. Oh well. Yes. Where am I dumb? If move both head.next and lag.next.
Ariel says, hey bro, how are you? To Rathanael says, lead and lag point to head. You are moving them one step at a time. You gotta move one twice and the other once.
I am though. I thought. Head, and I have lag, right? Then I have false here. So head moves, right? Head's here, okay? Now this comes to true. Now we move both. It's here, lag's here. Now this is false. Now we just move head. This becomes true. Well, we can't move this forward. Head down next. Oh, thing is lead and lag are pointing both to none. Oh, this sucks, dude. So move it 2 steps ahead. It'll just reach the end while lag is at the midpoint. So if lag is at the midpoint, I can't add to the end. So what if I instead wrap it back around? So what if I set lead equals to head, lag equals to head. I say while lead while lag right? I say let's move if head dot next, no, if lead dot next is equal to none, then we're going to set lead dot next equal to head. And we're going to set so once we wrap back around, our leader is actually going to become our lagger, but it's going to lap, and then we can evaluate right here, right, while lag we could say while true or something, I don't know, while lag here, can we say if lag equals to lead, right, we're pointing at the same thing. If lag equals to lead, so we need to advance our hair to actually lap and catch up to the lead. We need to advance our leader. We need to advance our leader to actually lap and catch up to the lagger, and so that they're at the same place. And that'll be that means that so it'll lap and start back over. So then the lagger is actually in front, but it's technically behind by one lap around. And then you can just check incrementally at each step right then and there. So if lag equals to lead, right, then we're going to call lag.next and lead.next. We're going to say lead equals to, or we're going to say lead equals to head here. Or start it back over. Right, say while lag, if lag equals to lead, then move them both forward until here, else return false right here. And then at the end of this loop, we're going to return true. So then while lag, so if the lead.next does not come up to a none value, then we need to move lead.next forward.
To Raffinail says return false.
If lead.next is not equal to none, so we caught we didn't catch it, but so in my example, this is what we're doing. So we have 1 that goes to 2, that goes to 2, that goes to 1, right? Oh my gosh, come on. Oop, there it was. Okay, so our lead and our lag is here, right? The lead is going to go 2 steps for every 1 of the lag. So if the dot next or the dot next or lead dot next is equal to none, we're going to reset it back to head, right? So in the case that we're on here, if we can't go from this one and go to the next one here, we're going to reset to head, right? If we're on this one, because we're having an odd number linked list, well, always actually, if it's dot next actually, because lead, if it's an instance of 2, even 3, it'll go up to here, hit the end, call dot no, so yeah. So if or dot next, we set lead while lag equals, we return false else, and we say else lead equals to lead.next. Oh yeah, my bad. So if the lead.next is equal to none, or if lead.next is equal to none, we're going to now our value our lead is looped back around, and we're going to evaluate while there is a lag until our lag reaches the end, right? If lead equals to lag.next, lead.next. And then this will come back here. Lag is still in play. If lag.value equal to lead.value, right, then .next. Oh, I keep doing this. Another infinite loop. Oh, we gotta move lag next. Move it forward. So what happens if we just move it forward right off the jump? If we say if lead is equal to none. Still infinite. Oh my gosh, dude. While lag, if lead dot next equal to an or, if the two values from now are none, then we're gonna no, because if it's equal to, oh, hold on. In the case where it's 3, you would skip it's 3. So let's do like this. Let's see in the case of where it's like 1, 2, 1, right? Hare and turtle. This would go all the way up to here. This would go up to here. Now this would then rotate. Now hare is back to here. We can evaluate if that is equal to there, which it is. So if lead dot next or lead dot next equals none, we set lead equal to hare head. And so while lag if lag dot value equals to lead dot value, because here our leader is going to get to here while our lagger is here. Then our leader is going to go to here while our lagger is here. No, because so to here goes up 1. The lag does not. Skips 2, then that goes. And that skips 2, then that goes. And that goes 1. So if the if we catch it, we'll have caught it. The thing for this one though is lag is here. The lead is here, the lag would be here. No, because we need to check if it's a palindrome. Set it to we set next to here. I would like some advice on Leet code 234. I am trying a rabbit and turtle approach, but I'm just not wrapping my head around it. Don't show me code. Determine whether a single list is a palindrome. Find the middle of the list using 2 pointers. Slow moves test. 2 steps. When the fast reaches the end, slow will be at the midpoint. Reverse the second half of the list. Once you find the midpoint, reverse everything from the slow end. So I have to keep track of a previous. So you get to the end here. Oh, so then when I get to the end, I would need to, so my head needs, my turtle, my lead needs to, as it moves, set its next value to its previous. So then when it gets to the end, it set its next value to its previous, so then it can go backwards.
Proxinote says, so I came from YT, seems like YT chat is not working in Eastern Standard Time, not sure, so by assignment, I meant head equals head next, you never assigned next to current.
YouTube chat's working. You never assign next to current. I'm reassigning lead as the next value and lag as the next value. I'm gonna ask, what's the infinite loop going on in my current? These lines do nothing. You're referencing lag dynamically. I'm not assigning them. Oh, I'm so dumb. How did I not see this? So this won't work because it's not the right approach, because we need to... Okay, so let's go back. So lead equals head, lag equals head. Okay, so let's go while lag, right? We're gonna say if lead dot next is equal to none, right? If the next value for lead is equal to none, or the next value is equal to...
says yes, this is a singly list, circular does not apply here.
Yeah.
End of point says oh nice, some POOP, Python object-oriented programming.
Okay, so while lag, so if we say, because our lag is going to be what goes all the way to the end. Or we say while lag does not equal lead. Because they're going to meet back up in the middle or somewhere. So what if I just move how do I do this? Let me set lead to head dot next and lag to head. So I'm going to say lead previous is equal to lead. Okay. Then I'm going to say lead dot next lead is equal to lead dot next. We're going to move lead forward, and then we're going to set how can I reverse it? I can't. Oh my gosh, this sucks so bad. So while lead, we're going to say lead dot next forward. So if I move those next dot next, so I say, or I could just say flag. I move both. Let's do false. And if we move both, we're going to set those equal. Right, else we're going to, if no move both, set lead equals to lead dot next. So that'll move it all the way through, right? So we'll move both equals to false while lead. If move both, lead equals to lead dot next, lag equals to lag dot next. Else we just move forward lead. So I'm going to take this, I'm going to give it, okay. This is what I have so far for finding the mid on the lag. Oh, I'm missing my thing. Move both true. Equal to true. This is a variant. You're moving lead one node at a time. Lag starts every other. The logic won't stop when lead reaches the end bit. Your lead moves 2 steps at a time. So if we set them both equal to head, say while lead if this is lead dot so if there is no dot next, so if I go because it might not happen. I can throw an error. Oh, this should be lag, sorry. Well, fast and fast.next are not equal to null. Lead and lead.next, right? Because if you have a next value, you can go to null, but if you don't have a next value, you'll go too far. Yes. So now we've caught up. Right, we've caught up with. So now we need to reverse. Reversing lead.next
Tirafinail says, Step 1, find the middle of the list using lead, fast, and lag, slow.
Yeah, we already got that. Now we're trying to figure out to reverse the list so we can start comparing values as our our lead comes back to the lag. But I can't, it's a singly linked list. Right, because right now my lead is here on the 1 and my lag.
Tirafinail says, Step 2, reverse the second half of the list.
This moved 2 steps. This moved 1 step. So so this moved 2 steps. So my leader is here and my lagger is here. So I need to reverse, and then I move 2 steps, I go to null, and my lagger goes here. So now I need to go backwards, but reversing the...
Proxinote says think about regular reversal in an array, same concept, but with pointers you need to reverse the pointers.
I know, but if we move forward... I know, like, we can set the pointer to the previous value, but we moved forward. We lost access to the previous value. Like our lead and our lag are on, so our lead is on none, and our lag is on this 2. So it's going to try to point back. No, so we pushed our lead up 2 places, and our lag pushed up to the 2. So we have our lag and our lead here. Push up 2 places, and our lag pushes up 1. So now our lag is here and our lead is here.
Tirafinail says prev equals non, cur equals lag.
So if we... It's not getting it.
Tirafinail says while cur, do something. Proxinote says create another pointer like another lag and lead.
So if we have 1, 2, 2, 1. So we have our hare and our turtle. Right, our hare moves to here, and our turtle moves to here. Now our hare moves to here, and our turtle moves to here. So our hare is on a none, and our turtle is on a 2. Goes to none. So the head is on none. If I reverse back to the 1, so if I set head to B, is what is confusing me. So I need to maintain reference of its next node. But the thing is, if I'm on a current node, I save the reference to the next pointer. I update the node to the reference, while also keeping notice of the previous. If I set that node next value to the previous, then I'm just going back so once you move forward from a node, so if you have a node take, this song sucks. Okay, so if I take a node, I'm on none here, and I'm on 2. So reversing this does nothing. This takes me back to 2 and then to 1. This takes me from 1 to 2. But if I reverse this, if I go back and then start the tail end over, back to head, that would do it, right? And then they would meet back up in the middle somewhere. I'm getting tired though. I think I might get off here. Been using my brain for too long here. Okay. Okay, so if I'm on 1, 2, none. And I want to reverse this. Okay, I have current, which is 1. Current.next is 2. So I say next is equal to current.next. previous is equal to current. Current equals to next. But the thing is, if I set current to next and then set current dot next to previous, it'll still move forward. Okay, so like lead equals to line.
Raphael says you are on the right track.
Now once lead and lag dot next, we're gonna say, so now we have a none. We're gonna set to reverse. So 2 then would point at 1. So which one do I want to reverse though? So the none will point at 1, which then points at 2, which then points at 2. If I set the 1 back, the lag back to 1, and reverse the list as I go for so if I say lead is equal to lead dot next dot next, so I need to reverse one of these lists. But which one? The 2, 1, none, or the 1, 2? I need to reverse this one, the leader list. If I reverse the leader list, then it goes none, 1, it goes to 1 to 2, and then back to the 2. Whereas my lag will then go 1 to the 2, then back to the 2. So then that is palindrome, that's true. So if I go lead.next equals to lead.
Internet says hello.
So I say then, which would I reverse the leader list and set the lag back to head and then match values, or no?
Internet says do dry run on paper.
Bro, come on, don't come in here and start making commands. We've been walking through it for a while now. Should you reverse the leader list or reset lag? No, it's actually the other way around. Lead is the fast pointer, only used to find the midpoint. After this, you don't use it anymore unless you're restoring the list at the end. Lag ends up at the midpoint of the list after the fast/slow loop. Use the lag to reverse the second half of the list. Okay, so if our lag after loop lag is in the midpoint. Reverse the second half of the list starting at the lag. Now you have two parts. First half from head to midpoint, unchanged. How do we have two halves? Our head is on none. Oh, because we have a reference to our original head, which is up to the midpoint as normal. And then we're going to reverse the back half with the lagger so that we can then send the lag back forward to meet with the head and check values. So send the lag all the way through reversing values from mid to end, then compare from head to mid and lag end to mid. Use the lead and lag to find the mid list. When the loop ends, lag is at the midpoint. Reverse the second half of the list starting from the lag. You reverse in place, so now the second half points backwards. This gives you a pointer to the new second half, to the head of the reverse second half. Okay, so then let's say while lag while you have a value for lag, while you have a lag dot next, right? You want to stop one shy. No, you want to stop while lag. Right, you want to stop while it doesn't equal to none, while lag.next is not equal to none, which will end the break out of this loop when you get on the last value of lag. Okay, so we're going to say previous is equal to lag, next is equal to next. We'll say next is equal to lag.next. We say lag is equal to lag.next, or just next. So that if we set the previous, we get reference of what we're currently on, which is going to be our new previous value. So previous is equal to lag. Then we gain reference of whatever lag's next value is too. We update lag to become that value. And we set what? Lag.next equal to previous. So this will save the previous as current. We'll get the save reference to the next one. We'll move it forward. And then previous is equal to lag, and then next is equal to lag.next. So we gain reference to both what we're currently on and then the next one. We move it forward and we have it point backwards to the previous. But the thing is, if I call next on that, then it's going to go back. You're moving lag before reversing lag.next, which causes a point of confusion. After
Offhand Schaufless Entity says, cheap viewers on streamview.com, remove the space, GTQHW rocks.
store previous and none. So we say previous equals.
Proxinote says, but Michael, if you are reversing, the last value needs to be none, so prev needs to be initialized to none and the lag needs to point to previous. How to do this? Think about storing lag next to temp before assigning it to previous. Save lag.next into the next node. Next equal to lag.next. Say previous is equal to, we're going to say lag.next equals to previous. Previous equals to lag. So we save reference of next, we update previous to equal the current value. So let's say that we're trying to reverse this, right? So we're going to say we have none here. We're going to save value as next is 2, right? We're going to save lag.next equals to previous. Lag. Yeah. And now that you've reversed it, set 2 pointers left and right. Now that you've reversed it, right runs out and becomes none. So I say L is equal to the head, which is the start, and R is equal to lag.
no, lag becomes none, and so previous, right, previous becomes the head because lag moved forward to none, meaning previous was stuck, right? So here lag moved to here on none, and then the previous is here as the head of the reversed list. So we say while R, right, if L dot value is equal to R dot value continue, or I guess we could say, we'll just say we'll say return false here, and then we'll come up here and change this to not equal. So while R is not none. Oh, we need to update. Whoops. So if it is, we're going to update L equals L dot next, R equals to R dot next. Dang, still not that fast. We solved it, but it's still not that fast. This still skip the middle node and on linked list doing comparison. The full second half. So if not hit, or so let's find the midpoint. Fast. Reverse it. Compare both halves. slow and fast both equal head. We do this. We reverse it. While lag. L is equal to previous. The first. This is the same thing I have. This is the exact same thing I have. So if I put this into it, is it the same speed? Yeah, about. I mean, it's a little bit faster, but it's pretty much the same code. Oh, well, he has some edge cases, right? So, so if you throw this on there, right, and you submit that, does it improve it a little bit for my second submission? Yeah, so that simple edge case just makes it so that it stops that one run. Oh, interesting. Right, so this is no different than that except for that one edge case check at the top. But it's a lot interesting. All right, you guys, that was a lot of Leet code today. So, I appreciate you guys' patience with me as we went through that one. I was able to use it with a string really easily, but using constant space was a little bit more difficult. Sheesh. Oh my goodness. Beat after that one, guys. Ooh. Dog's freaking out. What the dog doing? All right, what should we do next, you guys? The night is late here. What should we do next, everybody? Let's check the celly here. Check the celly. See where my lady's at. I think she's almost done. Try to check in on my lady friend here, make sure she's alright. She should be good. Alright. Nice. How many problems have we solved so far? 70. Woo! Hey, if we got one more sub, we'd be at 2270. So it'd be perfect. 70 leak code problems for 2270. So if you guys are out there, hit that sub for 2270. All right. I do wanna, let's go do one little thing on our project here, I guess. Okay. So what I wanted to do here is in our web scraper right here, right? I need to reformat how we're getting this information. Our compound cache is, right? So I'm going to delete this compound cache, go to our web scraper. So get description. Compound description. So the get description function we have here that I wrote, I'm going to delete this out. We're going to say return a dictionary, right? And we'll say, okay, then here we'll say this is compound description that's got returned. So compound description equals this description, and then we're going to duplicate this down and call this reference. This ref. Okay, so now if we run this, oh, so this goes description. We'll put this here. All right. Oh, I don't know why I write it or remove the right. Wait, what? Why this not cache results? Oh, that's happening in my main function here for cache. So let's open this up. Let's go get status. Let's go get add, get commit. We'll say reformat description. And reference returns for compound object. Push that up. Okay, so now let's go here and go cd backend. Let's go uvicore main app reload. Let's open this up. Detail not found. Okay. So if I write something here though, if I say just @app.get homepage, right, and then I just say return def home, right, and then I just say return test. There you go. Okay, so our endpoint, so that just home endpoint is linked. So I'll just go here and go added home endpoint. Okay, so now what I can do is I'll call /absorption compound. Oop. And then I'll put question mark equals to Michael here, and we should get the error, right, that this compound doesn't exist. Or missing compound name. Is it this? Question mark compound equals to, oh, question mark name equals to, okay, if I say Michael here, invalid, perfect. Now if I give one that's valid, such as caffeine, and I open up our cache, which is empty right now, so nothing's there, we get caffeine, and when our cache loads, there's caffeine, and now are we set up appropriately? We have description and disk ref here, perfect. So now what we can do, now that we have those separated, is we can go here into the SpectroSim page. We can apply comp name, comp description. I'll say test description, right? And then I'm going to call, the description is going to be here in comp data description here, paragraph right here is going to be comp description. So now if I go onto our Zish here and go cd front end npm run dev, okay, this is what we're getting here. Now if I go to simulators, come SpectroSim, okay, we have test description. Now let's go ahead, set compound data. So we're going to do, there is no title case here, so we're going to do set compound description, compound data description, and then I'm also going to come here, okay, that's fine. So now if I go aspirin and search, aspirin fills their description is empty. So then if I go to my title,
Nug says, oh damn, this looking nice. NPY edit says hello.
hey, how's it going, guys? Yeah, that's looking pretty good, huh? Welcome. How's it going, guys? So we have compound names going there. Compound description is here. So So then what's different here though? Why is this not updating? Because we cached aspirin, which was here, so we should be pulling this. See if I go caffeine, then it updates, but it's not pulling description. Are we doing anything here with the compound name that we aren't with description?
NPY edit says, so I am new here, could you explain what you are doing?
Yeah, so I'm writing a full stack website here using React, Tailwind, Python, JavaScript to display absorption spectroscopy simulators. I have a degree in human biology and a minor in chemistry, and I work as a formulation chemist for a biotech company. And so I'm using some of that knowledge to pull information. We wrote a web scraping script to actually get information from PubChem, their database, and then we're using that information to actually generate absorption spectroscopy predictions or simulations using Gaussian distribution and Beer's law, which are two just basically kind of models or functions basically to kind of make bell curves for absorptions at various concentrated wavelengths, which are our X values. So the thing there here, name, if not name, return name, get the name, await the response, data comment log, console log, set compound data name, compound.name, compound, oh,
Nug says which law?
Beer's law. Or is it Bear's law? Beer's law? Okay, so we have compound data dot name. Compound data dot name. What is name here? Oh.
NPY edit says you have thought yourself so much.
Compound name. So we have a description here. Okay, that's why we're not getting it. It's dot description. So now if I refresh and I type in aspirin, yes! Woo! Look at that, you guys. We're getting the stuff we parsed from the web. So now if I type in like let's type in something we don't have in our cache, right? So we only have aspirin and caffeine. Now if I type in, let's do benzene. So it failed there. Okay, that's fine. So benzene.
Nug says nice.
There we go. I spelt it wrong. Benzene. Woo! Look at that. It populates it. Oh, okay. So now we just need to title case this. Okay, so let's go. We'll go here.
Nug says, why'd you choose to use React as opposed to just JS?
I've used well, React is more of a kind of combination of everything, right? So in my SpectroSim, my TLC, my chromatography simulator, ChromaPlot, I use just raw vanilla HTML, CSS, and JavaScript there. So I wanted to level up. And so in my portfolio website, michaeldeming.com, I used React and just vanilla CSS. And so now in this one, I'm using Tailwind. So you guys can see my website, michaeldeming.com, if you'd like to check that out. So now let's go ahead, let's go git add here, git commit. We'll say linked compound description page population. Git push.
I got it right. You were gonna ask me. So fucking weird.
Hold on, let's still stream and let me wrap it up. Flashbacks to last night. No comment. All right, guys, I'm gonna wrap it up here in just a second. I'll stream until 10:30, about 8 more minutes, and then I'll wrap it up. My lady just got back from her movie, so we're gonna hang out. So yeah, we're building SpectroSim right now, and we successfully linked up the backend to our database to getting and populating the front end with the information, right? So then we're gonna link up these little things, and then we'll link up the graph generation too, which will be awesome. So that being said, let's go ahead and add in, like if we do benzoic acid here, that's not in here. And see, benzene got saved in our cache. So if I do benzoic acid and search, there it is. And then it got added here. Let's go. Okay, so now we need to title case this, right? So let's go to our, I'm going to go and delete this so we can get it to refresh here, and then I'm going to go back to our web scraper, and we are assigning the name at the very top here, right here. So we're assigning name equals name.lower. So the thing is I want to, when we cache this result, I'm caching.
NPY edit says, so when are you going to do another live?
Tomorrow. I stream every single day. I stream every day. If you go to my lives on my YouTube, you can see that it's a daily thing here. So you can catch me back tomorrow, NPY. Make sure you sub along and join my Discord link down below where you can get access to all of my resources. Or I've outlined it to you guys pretty neatly. And you guys can just chat with me there and hang out with me. So I'll stream for about 5 more minutes here, and then I'll be back tomorrow, or I'll come back maybe for a late. I know I say maybe. I always throw that. It's a very low chance, but I come back for maybe a part 2 and after hours, if I have enough energy once my lady goes to bed. Okay, so we're going to here. We're caching stuff. We're dumping the content onto here. I'm going to say dot lower here, right? I'm going to say dot lower here, and then in here, in my web scraper, I'm going to call this dot title. Right, so now if I run this.
Nud says, is this project on your GitHub?
There we go. So now we get aspirin in title case.
NPY edit says, what if the cache is too much, like if the file gets too big?
Well, if it gets too big, I don't know. It's only text data, so it's not.
It says big I man.
It's not going to get like too crazy. But we should be able to fast access these items because they have unique keys. So we're not looping over these, so it's going to be quick, and we're accessing this constant via its hash or its key index, right? So it'll be constant access. So right now we're getting aspirin title cased in the name here. And then the thing is do I want title case it here as well?
Nug says we were using raw JSON as some data at my old job and the files got up to 20 GB LMFAO.
Lots of data. So if
Nug
found
says, but
compound.
you don't need to worry about that at all yet.
So I say content dot get name. Found compound given this name stir. I force it to lower. Okay, so you all keys are lower, but their names are titles to display. So you force to lower for a search for that key name. So I'll make a comment here. Say keys compound names forced to lower for consistent searches. Right? So then but then what happens is that you save name equals name dot lower. Yeah, this is fine. You index into the compound date gets name, you save this into content, and then you write it onto content. Yeah. So now if we refresh and we go test, search, nothing pops up. So I do need to have some error checking. So here, right?
NPY edit says you write clean code more than me, big respect.
Nice, dude. Yeah, we've been coding a lot here, so a lot of hard work. All right, real quick, guys, before we wrap up for today, any last questions? Let me know if you guys would like to know any last things, but I'll be back tomorrow, so never fear, we'll be back tomorrow. I know we did a lot of Leet code today, so tomorrow we won't do as much Leet code. We'll do more stuff on the project. We're also going to continue on with calculus tomorrow. I've been teaching myself calculus, and I've been kind of slowing down just because the math is important, but I do want to stay really focused on the actual coding in my projects. That's what's most important. And then building math skills and Leet code skills on the side to then feed into my projects and programming. But what I really, really care about and passionate about is my projects, because that's what's going to get my foot in the door for a recruiter. I have to have a recruiter look at my projects and see them as valid and worthy enough to actually get me the interview. And then I can focus on like Leet code stuff for actually passing interviews and stuff. So the project is actually going to be the first barrier to entry, really. So that's why I'm like to focus on these projects and get them.
Says, so what is going wrong with it?
What's going wrong with it? Not. I have to right now. I just need to fix right now. So if you don't get a successful search via sorry. Here, right? I'm gonna print. Try this, except for right. So if I call print e here, and I refresh this, and I do test for something that's not there. Right, invalid compound name test. So on these raises here, if I receive a value, if I receive a error 404, then I need to not do these keep these by default, so I'll have to figure that out. But if I type in benzoic acid here, which is not in our cache, and search, I get benzoic acid populated right there, description, benzoic acid, and then I get it added here to the cache. And so then what we'll do is we'll populate the spectral data, and then we'll use that to actually generate plots with Plotly.js here. I was generating plots before with all in Python, but then I decided to convert to Plotly, so it's currently kind of broken right now. But I had it all working in Python, but I wanted to render plots on the front end so that they can be, the users can interact with them. They can like drag and zoom on these plots. With just static Python images from Matplotlib, it wouldn't have worked like that. So that's why I decided to do it this way. But so far it looks really, really cool. We also need to update this search status here to also indicate for successful and failed searches on these runs, which we'll have to focus on tomorrow. So anyways, you guys, we were able to get the title case going for the names, populate both the name and the description, and then, yeah, which is really nice. So I appreciate you guys for joining me, and thanks so much for being here. I'll see you guys either later tonight, if I had to do a part 2 after hours, or tomorrow. So thank you guys so much for being here, and my name is Michael. I am 26. I got a degree in human biology and a minor in chemistry, and I've teach myself to code for about a year now. So thank you.